Well, AVL tree is a height balance binary search tree. Okay. So it is a, first of all, its first point is it is height balance. Height balanced. What is balance factor? Balance factor. Balance factor, it is either -1 or 0 or +1. +1. Okay. So -1, 0, and +1. Now, balance factor is defined as a difference between the height of the difference. It is the balance factor is defined as the difference of height of left subtree and height of right subtree. Okay, so it is defined as uh, h of h of your tree, its left subtree minus height of tree, its right subtree. Okay, so this is the right subtree and this is the left subtree. So suppose this is a tree. It is a binary search tree. It is a binary search tree. Okay. Now, what is the height of the left branch? If we consider this is the root. Okay. So actually left subtree, its height is h of TL, your tree, its left portion, and this is the height of the right subtree of your tree. Okay, so this is your balance factor, HTL minus HTR, height of left subtree minus height of the right subtree. Okay, now actually this should be less than equals to 1. This is the balance factor, less than equals to, this should be less than equals to, actually mod of HTL minus mod of HTR, this is less than is equal to 1. This is the balance factor of a particular node. Now, for the last node, this is the last node, leaf node. Its left subtree, height of the left subtree is 0 and height of the right subtree is 0. So HTL minus HTR for this particular node, this is 0. So balance factor of this node is 0. Similarly, what is the balance factor of this leaf? Balance factor of this leaf is 0. Similarly, balance factor of this
Sir,
node, yes.
sir, please repeat again, sir.
Let this is A, B, C, D, E. Let this is F. Let this structure, this is a binary tree, and it is a binary tree and binary search tree. Okay, binary search tree, for binary search tree, the property is left child is less than equals to the root and right child is greater than the root. Okay, so this is the BST property. Now, AVL tree is a height balanced binary search tree. You have to calculate the balance factor for every node. While computing the height of your binary of your AVL tree, you have to compute, you have to find out the balance factor of every node. So what is the balance factor of E? Balance factor of E, because E is the last node, it has no left child, no right child. So height of left child minus height of right child, this is 0. So balance factor of E is 0. Okay. Balance factor of C, it is the last node, it has no left right child, no right child. So balance factor of C is again 0. Similarly, balance factor of F is 0. Okay. Now, what is the balance factor of node D? Balance factor of node D, it has one left child, E, but no right child. So HTL minus HTR for this particular node D, it will give you +1. Is it clear? +1. Height of the left subtree minus height of the right subtree. It is, you have to compute this difference, and here this is +1. Okay. Now, what is the balance factor of B? Can you find out what is the balance factor of node B?
So minus
Minus
1.
one.
-1, because height of left subtree minus height of right subtree, this is -1. Okay. What is the balance factor of node A, root?
-1.
Is it -1?
Sir, minus 2.
Why 2? Because B and F lies in the same level. So here, in case of node A, HTL, what is the height? HTL 1, 2, 3. So 3 height minus H of TR, H of TR. So height of the right subtree. So height of the right subtree is 1. So 3 minus 1. So this is 2. If the left subtree is greater than, if the left subtree is greater than the right subtree, if it is greater than the right subtree, then positive value. Otherwise, if the right subtree is greater than left subtree, then negative value. So for A, the balance factor is +2. Okay. So for A, the balance factor is +2. Is it clear? It is the balance factor. Okay. So 4 types of rotations are there. LL rotation, next one is the RR rotation, LR rotation, and RL rotation. So how to declare a node, in AVL tree? Anyone, please? It is a binary search tree. Okay, so it is a binary search tree, and first of all, you have to, in C code, you have to define your node. How to define? Anyone, please? Any idea? First one is the left child. It is a binary tree. First of all, it is a binary tree. How to define a binary tree? In case of binary tree, left child, middle one is your data part, and then your right child. But here,
Height.
yes, It is associated with your binary tree. It is a binary search tree. Rather, it is a binary search tree. This binary search tree is associated with your height. So first one is the left child. Okay. Then you can write the uh, data part. Okay. Next one is your height part. Okay, height part, and next right child part. So struct node. So struct node. The first part is the left pointer part. Okay, so first part is left child. Left child. It is a pointer for recursive structure. Next part is your data part, and then height part, and then right child part. Okay, so right child, it is a pointer, and height, int height, you have to calculate int height, int data. So it is a binary search tree. So the insertion will always follow the binary search tree property. So first one, struct node LC, and struct node RC. Is it clear? So this is the node structure. This is the node structure, and this is the equivalent C code. Now, this is your balance factor. So balance factor is the difference of height of left subtree and right subtree. So mod of HTL minus HTR is less than equals to 1. This is the balance factor. And allowable values are, we know that the allowable values are 0, 1, 0, 1 and minus 1. Now LL rotation. There are total 4 types of rotation. This LL and RR are called the single rotation, and LR and RL, these are called the double rotation. Okay. So LR means anyone? Do you know what is LR?
Left, right rotation.
Left, right.
Yes.
Left to right. LR means left to right. That is that is inserted node in the inserted node. So these 4 rotations are required for insertion. Okay, so insertion in AVL tree. So insertion in AVL tree, it will always follow the BST property. Okay, but there will be total 4 types of rotations. LL means left to left rotation. RR means right to right rotation. LR means left to right, and RL means right to left. So LL means inserted node your inserted node, dynamically allocated inserted node is in the left subtree of the left child of parent node or node A. Okay, always read in this form: inserted node in the left subtree of left child, left subtree of left subtree, or left subtree of left child. Similarly, inserted node is in the right subtree of right child. Right subtree of right child. Right child. Right subtree of right child. Okay. So LR. What is LR? Any idea about LR? Any answer is acceptable.
Left subtree of right child.
Is it so?
I don't know.
It is a
Sir, it
left.
could also be right subtree of left child.
Yes, it is inserted node. Always read in this form. First scan the right one, then scan the left one. So inserted node is in the right subtree of left child Similarly, LR rotation. LR rotation means LR rotation first inserted node in the left subtree of right child of node A. Here node A is the parent node. Okay, node A is the parent node. Now let this is your node A. Okay, node A. Let this is the node B. Okay, and this is the
E.
left. This is the leaf node. Okay, this is right subtree. So right subtree of your root is denoted by A in this rectangle one. Okay, so this is your leaf node, and from B we are getting BL and BR. BL and this is your BR. This is the left subtree of B and this is the right subtree of B. BL and BR. Okay. Now insert. First of all, we examine the first rotation. What is the first rotation? At the first rotation is the LL rotation. LL rotation. So LL rotation means inserted node in the left subtree. So left subtree of left child of node A. So what is the left subtree of left child? A. This is parent node A. Its left child is B. Its left subtree is BL. Is it clear? Is it clear?
Yes, sir.
So insert the node. So insert the node X. Let insert the node X in this position. Insert the node in this position. So this is the scenario. So what should I do? Anyone, please? Any answer is acceptable. Ishan, are you there?
Yes, sir.
So what should I do?
No idea, sir.
So it is the LL rotation. LL means insert, always scan from right to left. Okay. So insert your node at the left subtree of left child. So this is the scenario. Okay. Is it clear? X is inserted at the BL. Now we have to rotate. This is a LL rotation. This is the LL rotation, clockwise rotation. So what is the new tree. What is your new tree? So B is the root. I will explain with the example. This is the scenario. B is the root and its right part is the B, its right child is A. Okay. A's right part is A R. A R. A R is the leaf of A, and this is your BR. This is your BR. Okay, and this is your BL plus X. This is the total BL plus X. BL. This is your BL plus X. BL plus X. So this rotation is called the LL rotation. Is it clear? Any confusion? Anyone?
Sir, why are we rotating it?
Okay, so this is the rule. So insert 96, 85, 110, 64, and 90. Suppose you are given these nodes 96, 85, 110, 64, and 90. Okay. So this is a binary search tree, right? This is the binary search tree. So here 96 is the root. 96 is the root. So could you please tell me what is the position of 85 and 110?
Left and right.
Left and right. Because this is a binary search tree property. So 85. So 85 and this is your 110. This is the 100. So this is less than equals to and this is your greater than. Next one is the 64. So 64, first of scan from root. So 64 belongs to the left subtree of 96. Now scan 85. 64 is less than 85. So this is the 64. This is the 64. Less than equals to 85. Okay. Next one is 90. So scan from 96. 90 is less than. Next scan 85. So 90 is greater than 85. So it should be at the right subtree. So this is your 90. Is it clear? This is the binary search tree construction. Any confusion?
No, sir.
Now insert 36. Now insert 30. Oh, before insertion, you have to calculate whether this is a binary search tree. Okay, this is a binary search tree. Now you have to calculate is it a height balance? Is it a height balance binary search tree?
Yes, sir.
Because 64 its height, its balance factor 0, 90 its balance factor 0, 110 its balance factor 0. Okay, 85, what is the balance factor of 85?
0.
Zero.
Because HL minus HTL minus HTR is 0. Now 96, for 96
One.
85 and 110 belongs to
Plus
same
one.
level. Yes, plus 1. This is plus 1. For 96 is a plus 1. So it is a height balanced binary search tree. So it is a AVL tree. Okay. Allowable balance factors are 0, 1, minus 1. Now insert 36. You have to insert in a binary search tree. So 36 will be which position? 36?
So left of 64.
Left of 64. Left of 64. So 36 is inserted here. 36 is inserted here. Now calculate the balance factor again. So balance factor of 36 is 0. 64 is
Plus 1.
plus 1. Okay. 90 is 0. 85. For 85, this is
Plus 1.
Plus 1.
plus 1. For 96,
Plus
Plus
2.
2.
plus 2. Plus 2. So you have to identify, the rule is you have to identify the node where the balance factor is violated. You have to count from leaf to the root. Suppose there are several nodes. Suppose there are 3 nodes starting from leaf to when you are scanning from leaf to root, you are getting 3 nodes where the balance factor are violated. Then you have to choose the first node that is nearest to the leaf, because you are scanning from leaf to root to get the balance factor. So you have to count the node that is closest to the leaf that is violated, where the balance factor is violated. Now here at position 96, the balance factor is violated. This is plus 2. So it is a LL rotation. Why LL rotation? Because your inserted node 36 is inserted at the left subtree of left child. Left child is 85. Left subtree is 64. It is inserted at the 64. That is the left subtree of 85. It is the left child of 96 where the rule is violated. Okay. Now, what is the thumb rule? What is the thumb rule? Here, at position A, the rule is violated. At position A, the rule is violated. So B should be the root. There is a clockwise rotation. This is the rule. So the analogous, it is analogous to 85 is the root. 85 is the root. Okay. So 85 is the root. So 96, the root. This will be the right child, and 110 is the AR, your AR. Is it clear? And this 90, that is the BR. So this BR is at the 90. It is at position AL, at position AL. Okay. And this is your 64. This is your 64 and 36. 64 and 36. First of all, it is a binary search tree. Every node follows the binary search tree property. That is, left child is less than is equal to root and right child is greater than root. Now we have to check whether it is balanced or not. Is it balanced?
Yes,
Height
sir.
balance?
Yes, sir.
So it is a height balance. So this is the rule. Left LL rotation. Left child inserted node in the left subtree of left child. Megha, is it clear?
Yes, sir, clear.
Okay, now RR rotation. RR rotation means inserted node is in the right subtree of right child. Right subtree of right child of node A. Okay, so first of all, uh, A. Let this is your A, and this is B, node B, and this is your BR, BR, and this is your BL. Oh, this is the BL, and this is your AL. This is your AL. Okay. Now inserted node. So this is a BST. Let this is a BST. Now inserted A is the parent node. Inserted node is in the RR rotation. We have to discuss the RR rotation. So inserted node is in the right subtree of right child. So right child of A is B. Its right subtree is BR. So inserted node is in this position. X is the inserted node. Let X is the inserted node. So this is the position scenario. So in case of LL rotation, inserted node is in the left child or left subtree of left child. In case of RR, it is the right subtree of right child. So in case of RR rotation, there will be a anti-clockwise rotation of node B. So B is the root. Now B becomes the root. So if B is the root, then left child of B is A. Obviously, this is your A, and this is, so A, left of A is AL. So this is your AL, and this is the BL. Actually, AR is the BL. Okay, so this is your BL, and finally, this is your BR plus X. BR plus X. So this is BR plus X inserted node. So this is the scenario. Let, so here insert in this insert 36. So now let 34, 26, 44, 40. Can you construct the tree? Using these nodes, can you construct?
Yes, sir.
Muskan, 9065.
Yes, sir.
How to construct the tree using these nodes? 34. 34 is the root.
Hmm. Then 26 will be right, left of 34.
34. 34 is the root. 34 is the root. Next,
Hmm.
26. So
26 right.
is the left child. 26 is the left. 26 is the left child, and 44. 44 is the 44 is the right child. 44 is the right child, and next one is 40. So 40, for 40,
Left of 44.
so this is your 40, and next one is the 56. So this is your 56. Okay, this is your 56. Now what is the balance? Balance of 56 is 0. Balance factor of 40 is 0. This is 0. Again, this is 0. So 34. For 34, what is the balance factor?
Minus
-1.
1.
Minus 1 is the balance factor for 34. Okay. Now insert. Now you have to insert. Let 65. 65 is insert. So insert 65. Insert 65. So insert 65. What should I do?
Sir, right of 56.
Right of 56 is 65. So what is the balance factor of every node? What is the node where the balance factor is violated? So
Sir,
this
30.
is this is 0. This is your minus 1. Okay.
Hmm.
For 44, this will be again minus 1. For 34, this will be minus 2. Okay. Now, what should I do according to the rule?
Sir, 44 will become the root.
So 44 is the root. 44 now becomes your root. 44 is the
Thir-
root.
Sir, 34 left of 44.
34. This is 34. This is your 26, 26, and this is your
56.
50.
So 40.
40.
Oh, अच्छा, हाँ, ठीक है, ठीक है.
40.
So 40 will be on the right of 34.
Yes, 40 is the right of 34 because it is the binary search tree. Okay.
Yes, sir.
Now, right of this is 65. So this is the balance tree. You can calculate the balance factor. So balance factor of this one is minus 1. This is 0. This is 0. Okay. 40 is 0. 34 is 0. 44 is again 44 is 0. Okay. So this is the balanced height balance tree. Next one is the, so this is the single rotation. So in case of LL rotation, clockwise rotation. In case of RR rotation, anti-clockwise rotation. Now LR rotation. LR rotation. So inserted node is in the right subtree of left child. Right subtree of left child of node A. So what is the scenario? So actually LR, this LR rotation, it is actually accomplished by the LL rotation followed by the RR rotation. First of all, LL rotation, there will be a LL rotation and it is followed by a RR rotation. Okay. So that's why this is called the left to right rotation. Okay. So let A is the root. Let A is the root and this is your let B. From B, let this is your PL. This is your left child of B, BL, and this is let another node C. Okay, another node C. So from C, you are getting CL and CR. CL, and this is your CR. CL and CR. Okay, CL and CR. And from A, you are getting the last leaf node. Let this is your A R. AR. Okay. Now, here we have to discuss about LR. LR means you have to scan from right to left. That is, inserted node is in the right subtree of left child. Okay, of node A. So this is your node A. So what is the left child of node A? This is B. Now right subtree of B is this
C.
C. Is it clear? Now inserted node, let this is inserted in this CL. This is X. You can also insert X. You can also append X in CR also. Okay. So in this case, what should I do? Any idea?
Sir, we will make C as root.
How to make C as root?
Sir, we will make C as root and the left child will be B and the right child will be A.
First of all, LL is followed by RR. So first RR rotation, next LL rotation. So first of all, in C there will be a anti-clockwise rotation. That is which rotation?
RR.
RR. So this is your RR. RR. LL is followed by RR. This is your LL. Next, again you have to rotate. Now you have to again rotate. Okay. So what is the scenario? The scenario is C is the root. C is the root and B is the left child. A is the right child. A is the right child. And from B, you are getting BL. Okay, no problem. BL. From A, you are getting AL. Sorry, AR. AR. This is your AR. Okay. From B, from B, right side of B, from right side of B, you are getting CL plus X. Okay. This is your CL plus X. CL plus X. And from A, the left child of A will be CR. Now, if you insert X at the CR position, then this will be CR. This will be CR plus X. Left child of A will be CR plus X. So first, there will be a RR rotation. So RR rotation is applied to C. Then again apply LL rotation to the C so that we can get C as a root. Any query regarding this LR rotation? Any query? কারোর কোনো query নেই?
So first we are rotating C and B, and then we are again rotating C and A.
Yes.
2 steps.
First of all, see your C node, you have to apply RR rotation. Next, again at the intermediate position of C, you have to apply the LL rotation. Let us have an example. Let 44, 30, 76, 16, 30. You have to construct the tree first. So 44 is the root. Now 30. So 30 is the next 76. Next one is the 16. and then 39. Then 39. Okay. Now you have to insert, let insert 37. So 37 is inserted. What is the position for 37? So first of all, calculate the balance. So this is 0, 0, 0, this is 0, 0. 44, the balance is plus 1. Now insert 37. So what is the position for 37?
Left of 39.
So this is your 37. Is it a balance?
Yes, sir.
It is balanced.
No, sir. No, sir.
This is 0. This will be plus 1. This will be plus 1. So this will be your minus 1.
1.
Minus 1. And this will be plus 2.
2 plus
Okay. So it is not a balance. It is not a balanced one. So your C node is the 39. 39 is the C. Here this 37. Here this 37 is inserted at the right subtree of left child of 44. This is the right child, right subtree of left child of 44. So here 39 becomes the root. So 39 now becomes the root. 39 becomes the root. Then
30 will be in the left.
44 is the A. So A is this. And your B is 30 is the B. 30 is the B. And then BL. So for BL, you can put 16 here. Okay, 16 here. And so this will be your
37.
37. Complete at 76.
76.
Sir, can you show like first with RR and then using LL two-step? Like with the same example, first you do RR and then LL so that we can see more clearly.
So first of all, first 39 is the C. Okay, 39 is the C. So in 39, what should I do? In 39, anyone?
Sir, 39 and 30 will be rotated.
So first of all, 39 and 30 will be rotated. Okay. So first of all, here 39 is the intermediate root 39. Okay. So 39 and next at position BL. So 39 here, this will be your 30. This will be your 30 and this is your 16, node number 16. Okay, node number 16 and this is your node number 37. And this is the 44. This is the 44 and this is the 76. কে কোশ্চেন করেছিল? মেঘা কোশ্চেন করেছিল?
Yes, sir.
So is it clear?
Yes, sir.
It is the left, it is the anti-clockwise rotation. So anti-clockwise rotation means RR rotation. Okay. Next, you have to do the
Left.
LL.
LL.
So in LL, in case of LL, so first 39 is the root. Okay, 39 is the root, 44 is the right, 76 is the right of 44, and then 30 is the left of 39, 16, 37. Is it clear?
Yes, sir.
Okay, now last one, RL. So what is RL? So insert a node in the left subtree, left subtree of left subtree of right child. Okay, left subtree of right child. Um, just one example. Left subtree of right child. Suppose এটা পারবে না দেখাতে হবে বলো তো একটা এক্সাম্পল একটা বড় এক্সাম্পল করে নেব should I explain this RL
Yes, sir.
so A
सर इसमें LL पहले होगा फिर RR होगा.
A RL yes first LL then RR so A this is your node number B this is your sorry A this is your RL RL means left subtree of right child right left subtree of right child so A and its that left one is A L left subtree and this is your B this is your B and this is B and left subtree RL so RL means RL this is RL RL means left subtree of right child so left subtree of right child so that this is your C and C has two child CL and CR you can insert any one of these at any one of these CL or CR CL or CR anyone okay anyone CL or CR and this is your BR okay BR let we insert the node let we insert the node X at the CL you can also insert X at CR okay no problem so X is inserted at the left subtree of right child of node A. So first of all, RL means RR followed by LL. Okay. So first of all, C, there is a LL rotation. Then there will be a RR rotation. So that C is the root. So if C is the root, then if C is the root, then left of C is A. Okay, left of C is A. And next, right of C is B. This is your AL. This is your AL. Okay, and this is your BR. This is the BR and this is the CR. Okay, and from A, this is Cl plus X, Cl plus X, Cl plus X. Is it clear? Any confusion?
No, sir.
So let construct construct the P, obviously ABL using the nodes. Using the nodes. So nodes are let 64, 64, 1, 14, 26, 13, 110, 98. Can you construct the tree? Should I explain the construction? কেউ আর কিছু বলে না, চুপ। এটা পারবে না পারবে না?
Yes, sir.
Construction তো
Yes, sir.
করতে হবে? So first element is the 64. So first element is the 64. Okay. Its balance factor is 0. Next one is the 1. So 1, what is the position of 1? This is the binary search tree. So
Left of 64.
1 is the left of. So is it a height balanced?
yes, sir.
So it is plus 1 and this is 0. So it is a height balance. Next one is the 14. So 14. So 14 is
Right of 1.
the right of 1. Right of 1. So this is your 14. Okay, 14. Is it a height balanced?
No, sir.
So this is plus 2. Plus 2. Okay. So which rotation is appropriate?
Sir, LR.
LR. Is it correct? LR?
LL.
LL. LR যেই হলো না LL?
LR. LR.
LR.
Sir, LR.
Why LR? Because your node 14 is inserted at, so the violated node is 64. So this 14 is inserted at the right subtree of left child. Your left child is 1. It is inserted at the right subtree. So it is a LR rotation. Yes. যে বলেছে সে ঠিকই বলেছে, this is a LR rotation. So LR rotation, after LR rotation, what is the scenario?
So 14 will be the root, 1 will be on the left, 64 on the right.
So 14 is the root. So LR means LL is followed by the RR. So first of all RR. So for RR 14 is exchanged with 1. Next 14 is exchanged with 64. So 14, this is 14 and this is your 1, 14, 1 and 64. Okay, this is a, and you can check, calculate the balance factor, it is balanced. Okay. So next one, so 64, 114 complete. Next one is 26. So what is the 26? So for 26,
Left of 64.
Left of 64.
so left of 64 is 26 complete. Okay. So this is 26. 26 complete. Next one is the 13. So 13 is the
Right of 1.
13 is the right of 1. Every time you have to check the balance. Is it balanced, height balanced?
Yes.
Yes, sir.
Next one is 110. Next
Right
one
of 64.
right of 64. So 110. Again, it is a height balance tree. You can check the balance factor of every node. Next one is 98. Okay. So 98. So 98, what is the proper position of 98?
Left of
of 100.
110.
Now, is it a height balanced?
No.
No, sir.
কোথাও ভায়োলেট করলো বলো তো? This is 0. This is plus 1. This is plus 1.
Yes, sir,
Again,
it
this
is
is
balanced.
0. If this is 0, this is minus 1. This is your
Minus 1.
minus 1. And this
Minus 1.
Balanced. Balanced.
minus 1. This is a balance.
Ah,
98 is balanced. Next one is 85. 85. So what is the position for location for 85?
left of 98.
Left of 98. Left of 98 is 85. Now is it balanced?
No, sir.
So this is 0. This is your plus 1. This is your
That's true.
plus 2. This is 64 is
Minus 2.
Minus 2.
14
Minus 2.
minus 2. Now there are total 3 nodes, 14, 64 and 110. Total 3 nodes where the balance factor is violated. So first of all, we have to consider which node? We have to consider which node?
सर 14 का
110.
Megha?
सर हम पूछ रहे हैं 14 का -2 कैसे हुआ? -3 हाँ ठीक है ठीक है
Clear?
हाँ यस सर क्लियर
Okay. Now there are 14, 64, 110, total 3 nodes where the balance factor is violated. We have to take which node?
Sir, 110 maybe.
Not maybe. It is 110. Why? Because if there are a number of nodes where the balance factor is violated, then we have to choose the node that is nearest to the leaf, because we have to calculate the balance factor starting from the leaf towards the in an upward direction towards the root. Okay, so which node is closest to the leaf? It is 110. So first of all, we have to apply the appropriate rotation at node 110. Okay, so which rotation is appropriate?
LL rotation.
ভালো করে ভেবে বলো। কুনাল তো কুনাল কুন্তল
কুন্তল।
কুন্তল which rotation is appropriate?
Sir, if we consider 110, then LL.
LL is the appropriate. LL is the appropriate rotation. If we consider, we have to consider the 110. Okay, so if we apply the LL rotation, then LL at which after the LL what is the scenario? LL means single rotation. LL means single rotation, and it is applied on 98. So
Yes, sir.
so 98 is the root. Okay, intermediate root. 98 is the intermediate root, and 85 is the left, and 110 is the right. Okay, is it clear? Next, 64. 64, and from 64 we are getting 26. Okay. Okay, so from 64 there will be 14. So from 14 we are getting 1, and from 1 we are getting 13. Now calculate the balance factor.
Yes, sir, it is balanced.
85 is 0, 110 is 0, 98 is 0, 26 is 0, 64 is
-1.
-1, 13 is 0, this is your
-1.
-1, and 14 is
-1.
-1. So this is the balance. Only one LL rotation is enough for, in this case, it is enough. Only one single LL rotation. Is it clear? So this is the entire rotations for AVL tree. So you have to construct, first of all, you have to find out the height of in a function, you have to find out the height of a particular node. Okay. In a small function, first find out the height of a particular node. Then using that function, you have to calculate the height of every node so that appropriate rotations can be applied. So AVL insertion is enough for you for your course. You have to implement the AVL tree.
Sir, what is full form of AVL?
AVL is the height. What is the complexity? Anyone? What is the complexity for AVL tree? Anyone? It is a complexity of AVL tree is a height of h. So height of h. So height of h. This is order of log n. It is actually order of log n. Order of log n. 1.44 log n. Actually, height is 1.44 log n. So it is order of log n. Now AVL. It is AVL tree. It is actually three. It is introduced in 1962 by three scientists, and their name are Adelson, Belsky, and Landis. Okay, the scientists invent this height balanced binary search tree in 1962. So A, Adelson A, Belsky V, and Landis L. First letter of their name, we have the AVL tree. It is a height balanced. It is a height balanced binary search tree. Height balanced binary search. They invent this tree at 1962. Okay.